Okay, so back when we did general physics, we had talked about the potential as being the gradient of the electric field. And in calc-based physics, we said that if you have the potential function, you could find the electric field by finding the slope of the potential function and doing the derivative with each spatial direction gave us that. And graphically, when we had done this, we were looking at those being, if I have a potential function that looked like this, then at any point along there, there's a slope. And the slope indicates the field strength. And so like if this is x and this is the position along the x direction, the slope indicated the field strength. And so in 1D we had things like it was minus the So if we have 3D, it's functions in x, y, and z, so we have to take the slope in each direction.
Okay. So it's just the 1D, it's just telling you, like, if it's
Just
x,
say on
y.
the x, okay? But we also had, from P401, that for a point charge, we could express the potential in terms of this simple equation. And it's not a vector. Q is our point charge. R is your distance to the point charge. And further, we saw things such as positive charges create high potential, and negative charges create low potentials. And if I were to, again, try to make a plot of this sort of thing, you might end up seeing something where near a positive charge, you get this sort of a thing. Near a negative charge, you would have a negative sort of thing, where there's a location here of a positive charge and here a negative charge. And we could calculate the potential at a single point due to a single charge. And I'll post on Blackboard for you guys, for my class, some of the example problems we had done back in 255. But this again lends itself to multiple charges, because if I had multiple charges, the net potential was the sum of KQI over RI, where again QI is an individual charge and RI is the distance to that charge. And computationally, when you have the sum over it, we can set that up either as a calculation looping over a list or potentially a matrix vector type calculation. Okay? So these are the equations, and we're going to look at them computationally just so you can get sort of a picture for what's happening overall and how I would calculate it individually. And then we'll come back and we will look at some situations where things are nice enough that we don't have to use a computational technique. We can actually simplify it using just XYZ coordinates. Okay? So that is our overview there.